So today we got K's smallest product of two sorted arrays. Integer arrays, positive, negative. They can be negative. As well as an integer K. Return K's smallest product. Okay. Okay. That is interesting. The lengths are up to 5 times 10 to 9. Well, okay, so for 4 we first have to consider these guys from backwards, and then -2 backwards, and then from 0 forward, 3 forward. What I think is that for each of these numbers we could keep its pointer, so these guys will have pointers here, and then these guys will have pointers here. And since this is O, K is O, okay. Okay, that's tough. K is less than their multiple, and their multiple can be 2.5 times 10 to 9. Okay, so we cannot just simulate it. How about we binary search for the value? So we binary search for the value of the product, which can be looks like 10 to 10. Worst case, or from -10 to 10 to 10 to 10, and then okay, and now how do we check fast if how many values are smaller than that? Well, we can check that in n okay, let's say we find I mean, we can check it in nlog and with binary search easily. Okay. So, okay. And then maybe we can think about optimizing it to n log k, let's call this k. So let's see. M is nums 2 size, then we grab like the minimum of nums 2 0 nums 1 0 times nums 2 n minus 1 nums 1 n minus 1 times nums 2 0 nums 1 n minus 1 times nums 2 n minus 1 and let's call this L, and then let's do R, which will be just maximum, right? So okay, let's call this left, why not, and right for clarity. So standard binary search formula, and so left, right, and now what do we want to do? Long count them, and then for each in n I want to do this, we want to do smaller one times logarithm of the larger one. So we want to do if n is over m, swap nums1 nums2 swap nm, like that. So we iterate over less elements, I mean worst case, but who cares. Could help when running many test cases because Leetcode. Okay, so let's do this, and then finally return this, and then okay. I don't know, let's call it left 2 because we are extremely creative. Left 2 is 0 and right 2 is, or let's say up to 0 elements, and then we have up to right is equal to, or let's do just n minus 1, while left 2 less than right 2, long mid 2 is left 2 plus right 2 divided by 2. And now what we want to check, if nums 1i times nums 2 mid 2, and now what is less than mid, then or less than or equal to, I should, or less, let's do less, at least m plus 1, right? What if there are ties? Are they distinct or no? They don't, right? They don't have to be distinct. Oh, it's one based. Okay. Let's see. I'm thinking about when we have multiple equal numbers, and because what we want to count the number of, how to even frame this, well, if we just count numbers that are smaller than what we are looking for, then we might get less numbers. And if we count including the equal ones, then we might get more. Yeah, whatever, let's just go like this. So this way we find the first index, wait, because if I'm at 3, I need to go from smallest, right? So I want to do this. If nums 1i is, good question. If nums 1i is under 0, then we do this update, else we wanna do I care actually? Because let's say I am at some position and then this is less than mid, right? Then I guess I wanna go there. I guess. So this is not necessary. Whatever. So left 2 is mid 2 plus 1, or otherwise right 2 is mid 2. Okay, so we end up with an index for which we know how many this should, if nums 1 I under 0, then we should do this, else right 2 is equal to mid 2, and now if nums 1i is under 0, then I suspect this, else left 2 mid 2 plus 1. Okay, and then if we have this, okay, so meaning we have a negative number, we consider the elements from the back. So wait, so the numbers are increasing in value going from here, and we get the first position for which it's larger than or equal to, let's say we check for 5, we get here, so we need to subtract all this, I guess. So except that one, so count plus equals, good question, m minus left 2 plus nums 1I times nums 2 left 2 is less than mid, else count plus equals left 2 plus I don't know, left 2 plus nums I times nums 2 left 2 is under mid, maybe, and then if count is less than or is less than k, then left mid plus 1, else right is mid, and then we output left. I have no clue. This is absolute dog water. It will not work. Left mid plus what the hell is this? Let's see what this does. Interesting. Why does it get stuck? Okay. This is on this output. Third smallest. What the hell? Okay, let's see. What? So this count should be number of elements that are smaller than mid. 16 of them. Wait a minute. That doesn't quite work out. Are there really... Wait, mid is 0, so we want number of that are smaller than 0, so 6 plus what the hell? So nums I nums 1I left 2, I guess. So mid is 0, and then minus 2 should also do this. This times this is less than mid, and if this is less than 0, then left is this. No. Should be like this. Because, and then maybe flip this. I don't know, we will get to that later. My days. Let's see. Okay, another 5 seconds. Oh, this will be a longest debug session. Oh my days. I'm not optimizing this to nlog, okay? Ain't no way. So 0, 1, what? For which it is larger than or equal to, but minus 2 times 2 is, that does not hold it. Okay, so needs to let's see, inner binary search debugging is nasty. So we have 0, so we want if it's smaller than 0. And what do we have? 0 and 2 is minus 4. Okay, so it's smaller. So what did you do here? So right is equal to this, and then you go to 1. So left is mid to, no. This didn't hold because we have mid is 1 and then product is 2 because we have minus 2 times minus 1. So that's larger. So left is mid 2 plus 1 and mid 2 was, so that's actually want this. And then on this, what I'm doing is that oh, three elements. Okay, then for this index it should be 6 elements. This maybe I should print I guess so. I count is 3, count is 6, count is still 6 for 0, and then it should be 8, 10, and it should be done and dusted. So we have what? Mid count. Okay, so for 0 it's 10, and since that count is what? That count is larger than k, then we set right to mid. So So we have -5 and the final count is 3. So number of products smaller than -5 is exactly 3, which is exactly what we wanted. So next mid is -7. There should be 2 only. Fair enough. So next mid is 5. Fair enough. And then next mid is 5 and next mid is 5 for some reason. That is great. Because this keeps happening. Maybe this will work. I have no clue. Oh, what the hell? That's exactly the problem I was skipping over. Maybe like this, and then this should be like this. -7 minus what the hell? So the count is 10, which is over, so we said right to, so it definitely cannot be this number. I'm a little confused on the counts, to be honest. Maybe this. I have no clue what I'm doing. That worked somehow. Okay, fair enough. Fair game, so we can technically skip this case. Okay, so for mid 13 we have 2 counts over that, so 20 and 15. That's weird. Okay. So this will be close to. Okay, so it's just off by 1. So, okay. So what I'm gonna do is just output left +1 and hope it works. Because that's how we do programming. Let's remove this so that it doesn't clearly on output exceed it. Okay, sample pass. 3 out of 112. I literally just passed these cases. That is ridiculous, dude. Ridiculous. this. Boom, let's see. Nothing will work, of course, as always. Haha. We get really interesting. Maybe this, and then we have to have like a get count or something. I don't know. So long cant get cant auto get cant is this. Okay, I guess that's fair game, and then we return count. Need. Okay. And now if cant get count left under k. Okay. This works on 4 cases. Okay, we get DLE. Where do we get this? Integer multiplication. Oh my days, are you kidding me? Vector long times 1. Let's do this useless copy because why not? Okay. Okay. You really cannot convert vector into vector long. Oh my god, bro. Why is CPP so dumb? This is like straight up impossible, dude. CPP problems in Python, this would have been done and dusted. 7 cases passed. Whatever, okay. Let's see if 8 cases pass. 80. Oh, that's better. Okay. Now we come into ties and now we are cooked. Okay, so there are ties. That sucks. Okay, so I guess we have the right answer, but I think it actually might be easier with the pointer because okay, let's add like a bool flag, and this should be minus flag, and then this should be minus flag maybe, and then I'm really stretching it thin here, but let's get count to what the hell, count tie, and then count less, and then what can we do with these? So if count less is less than k, then we go here, and then otherwise we do this, and then no, if count tie is less than this, then we for sure need to increase, otherwise we need to do this, and then finally we return. I have no clue what I'm doing, dude. Like, no clue. Probably broke it. I really didn't want to think about this case, but I'm gonna be very not slept well if I don't finish in next 15 minutes. Okay, let's say we get 15, so let's say we can get because let's say the sum is minus 15 for here. 4 by 9 is 36. Okay. The ties are a problem. And how do we solve them? I have no clue right now, but because if I have count of pairs that sum smaller than or equal to, then I might get a slightly larger sum. So if I get this and the larger is the number is I don't understand really why it shouldn't work, to be honest. Let's fix it back. Okay. I guess let's uncomment all this. So minus 6. So mid is minus 6, then the pointer whatever. So we need that are smaller than or equal to minus 6, and that's only 2. two of them because this is positive. 2 for this, and then 2 for this, 2 for this, then 8 for here. 1 2 3 4 5 6, and this, okay, so 6 is fair, and for this one it should be 7. Okay, so 17. Okay, so for 15 the count is 30, but actually it is not. Because let's say we would find out that the count is one is smaller and the other one is larger than or equal to. Because where do we finish up? Right, let's say I add the flag back, bool flag minus flag and then we do like here I just do true, and then here I do true, cant tie and cant less false. Okay, or so for 13 I get less than or equal to 9 to 9 to less than or equal to that's wrong test case, so we get minus 616 and minus 617. Yeah, because of this case, but both are less, so we don't care. So if cant tie is less, then we do this, and if it's over, else if cant less is over k, then right is mid minus 1, else right is mid, and then we are almost there. So for 21 we got 31 32, and for 7 we got 24 25. Both are smaller. Are you sure about that? Really, for 15? Why is it for 14 the count 28 is my first question. And why is it for the second one 28 again? So let's say we want numbers that are smaller than or equal to 14 for this array. This, and then that's 4 12. Okay, so 4 numbers. Okay, so for this one it's all of these, so 9, no, 10, 1 2 3 4 5 6 7 8 9. Ah, here is the catch. So what we got is nums I is minus 1 and left is 0, and then we got so minus this I guess. Maybe. I'm not sure. That's not great that I'm just guessing, but who cares? This is wrong, dude. Hell no. So if this is not true, so actually it should be this. And then here too. Okay, so for 14 we got 25 and then 25. Okay, seems to be 4 plus 9, and then with 5 we got this, so that's 7. Why 6 only? Why 6? Because this is what, minus 5? I don't buy this. Maybe it should stay this way, so if, let's see, got 27. 17 got 29 and 29 and 29 and yeah, that's weird. It should be false. Okay, almost got it. 6 smallest one. So we got smaller and smaller than equal to 4. 1, 4, and then 4 smaller, because this is gonna be 0, 0. Yeah, okay, that's fair. For 5, we got what, 6 numbers. Okay, so for 2 that's more interesting, but still 6. Okay, for 2, okay, I just did. So for 0 we got 4 and 6, and then wait, so which one's smaller though? Less should be less, I guess. That's weird. Well, looks like tie is, oh, wait, that's weird. That is weird. How does this work? If we have a larger number, then we get to some index, and if that is also, okay, that should work. So we want this amount of elements. So if we are at n minus 2, we want 2 elements minus this is larger. I'm not sure this will work at all. No, it won't. Still won't work. So left is what? How is left 1, dude? because 0 has 4 and 6 and I'm interested in this, so so at the end, left is -1, right is this, so mid should be 0. So if cant tie is less than k, so the larger one is less, then we should mid should be how is count, how is, I don't understand. So we are here, and then what we want? Numbers that are smaller than equal to this, smaller than equal to 0, which is select 2. So 2 numbers, so here, okay, and then here you got wait, count, and then if nums I times nums left is, well, the flag is 0, so if it is smaller than or equal to and the flag is 0, then we don't want to count ties. And if we want to count ties, then it's true, and it should be, this should be false, and it should be true. And then this should be, you want to get less, so that means I have no clue what I'm doing. Okay, I'm not optimizing for Owen. It could be done, but I simply am not doing two pointers. I am not doing that. No way. Oh my god, I can't believe I actually solved this. I have never done such disgusting binary search edge casing in my life. That is terrible. Oh my days. Okay, let's write up a solution because this is just plain disgusting. Okay, so since k can be up to 2.5 times 10 to 9, instead we have to do something faster than simulation in, I don't know, whatever, in okay, log n. We can do that with binary search. If we can since k can be up to 2.5 times 10 to 9, we have to do something faster than simulation. which is this. Why is this not removed? Okay, so comments removed. This is the worst code of all time. Oh my days. Okay, so why do we do binary search? Well, because notice that by what if we directly find the answer instead? Let's say we want to count the number of elements, number of products that are smaller than x. If there is less than k of them, we know we have to increase x, else we else to find the answer, else we have to and not increase it otherwise. Notice that for first x is going from the smallest possible products, there is less than k products with some of less than with products smaller than x, and then at some point suddenly, when for the first two x ans, for which there are more than or equal to k products, for which it's greater than or equal to, or are greater than or equal to k products smaller than x. And this holds for all x ans. Can you think of how to find the right x, how to find x ans now? The answer is binary search. since okay, only question remains how to find the only question remains how to find the number of products smaller than a given x. We can do that either with another binary search, to answer the last question, we can count such products for each of the elements in the smaller array. Let that be num loss of generality, let it be nums1. Okay, so given y from nums1, we need to count the number of elements such that their products are smaller than x. Since nums2 is sorted, we can just do this with binary search. Then we sum up all the counts for each y from nums1 and for each element of nums1 and check if it's less than k and adjust the search boundaries. One might notice that since nums1 are note that for negative numbers for negative y we adjust the search boundaries in the opposite way as we do for non-negative y's. To get the correct counts. One might notice this since nums are also sorted. Answer for y at index I. Total count of products featuring y at index I in nums1 products featuring y smaller than k is greater than or equal to the total counts of products for y y2 equal nums 1I. And for all negative y and what's that? It's increasing. No, if it's decreasing for this, then we have small number. So well, if I have 10 and then I have 2 here, then all these are smaller, and then suddenly if I have 0, 1, and if I increase it, then it's smaller. i.e. it decreases, and for positive consecutive y it decreases also. I think or increases, but does not matter, either is fine. Well, if I have -5, right, then I can go up to here, but with -2 the number can increase, so is smaller than or equal to the total count increases and for it decreases. Therefore, instead of just hammering the problem with the sub-problem with binary search, we can use 2 pointers for it to reduce the sub-problem complexity from O of min and m log max and m to O of I guess max, because I have to move through this, and then that's whatever, where n is the size of the smaller array and m is the size of the larger array. Okay, this is absolutely O of n plus m log let's call it max, where max is the range of minimum and maximum possible product. Since we do binary search on the product and each check takes O of n plus m if we use 2 pointers. If we use the oh my days, I'm so hungry and it's midnight and I'm working tomorrow. Oh my god. Okay, the space complexity is maybe 0 actually. I think actually it's like it's 0. It's 01 actually, since we only use a couple of extra variables. Interesting. Okay. Note. In the code I only do the binary search approach since I did not have the nerves to do the 2 pointers approach afterwards. Also there is a bunch of shenanigans happening since handling ties is a bit more complicated. You count number of elements, smaller x and smaller than or equal to x also. Okay, this is ridiculous. 1 hour 12 minutes and I didn't use a hint or look at the solution is crazy. Good night.